Hello, my name is Yash Devdhar, and our research paper is centered around free space optical communication, or FSO communication for short. In FSO communication, since the signal travels through air, it faces a unique problem where it is affected by external atmospheric disturbances such as rain, fog, hail, etc., and this is called atmospheric turbulence. Atmospheric turbulence affects the power of the signal, creating more variance in its average power. Devices that have traditionally been used in optical fibers, namely continuous mode optical regenerators or CMOs, should not be suitable for use in FSO communication as they are unable to deal with signals with high varying input powers. In our paper, we have used burst mode optical regenerators or BMORs in a hybrid FSO fiber model in order to understand their effect on the BER in the presence of atmospheric turbulence. BMORs were chosen since they are capable of power equalization and hence should perform well in FSO systems. In our model, the signal first travels through an optical fiber section where it gets affected by AC noise. Then the impaired signal is sent through an FSO channel where it is affected by atmospheric turbulence. Just after the FSO channel, a BMOR is present. After passing through the BMR, the signal goes through a cascade of 6 BMRs present in another optical fiber section. In order to gauge the performance of the BMRs, we have included two more cases. One where all BMRs are replaced by CMRs and one where no regenerators exist. Here you can see the equations used to describe the phenomena mentioned before. The first equation shows how AC noise affects the PDF of the input signal, and the second equation shows how atmospheric turbulence affects the impaired signal in the FSO channel. The third equation shows the calculation of write-off variance, which is a variable that decides whether the turbulence is weak turbulence or strong turbulence. In our paper, we have kept its value such that weak turbulence is experienced in every case. Finally, as the signal impaired by AC and atmospheric turbulence are two independent random variables, we have used the PDF transformation as shown here as the two random variables are being multiplied. For our results, we have taken two cases of average input powers and two cases for the nonlinearity factor gamma, which is a variable that controls the working of optical regenerators. All results obtained show that BMORs, the green lines, perform significantly better than CMORs, the red lines, making them a better choice for use in FSO systems. Furthermore, for high average input powers, which are the figures on the bottom, it can be observed that further along the cascade, the case with no regenerators performs comparably to the case of CMORs, while BMORs still perform the best, further proving that CMORs cannot be used in FSO systems.